Okay, so this is a lesson about graphing linear inequalities, and the important thing to note about graphing linear inequalities is that just like solving inequalities is just like solving equations, graphing linear inequalities is really just like graphing linear equations. And so if we're taking a look at y is less than 2x plus 1 and we want to graph this linear inequality, we really want to start by thinking of it as if it were the equation y equals 2x plus 1. Because ultimately, we're going to use this as a sort of boundary to help graph this and really understand how to apply the inequality part where the equal sign generally stands. Okay? And so if we were graphing this, we have a few different methods. We could either plug in values for a variable to find the other variable, or if it's in this form, which is slope-intercept, we can use that to our advantage. So, given the y-intercept, we can plot this point, 0, 1, and then we can use the slope. The slope is 2, so that means a rise of 2, a run of 1, so we can go up 2 over 1, up 2 over 1, and so on and so forth. Okay? I just fill it in with a few more. All right, and now I'm going to draw this line. Okay? But what I'm going to do here is, in this case, rather than make it a full regular line, I'm going to make it a dotted line. And the reason is because if we're graphing the linear inequality, y is less than 2x plus 1, what we're ultimately looking for are the values on a coordinate plane that make this true. And if we actually think about the points that we graph to plot this line, they don't actually make it true. For instance, take the y-intercept. This was the point 0, 1. Well, if we plug in 0 for x, we get 2 times 0 plus 1, and y equals 1. Well, that makes a true equation. But if we plug it in here, it doesn't work the same way. If we plug in those values, that is 1 for y and 0 for x, we get 1 is less than 2 times 0 plus 1. Well, is 1 less than 0 plus 1? It's not. And because of that, all of the points on this line are going to be a boundary rather than actual points, and so we draw a dotted line instead of a full line. Okay? Now, there's more to the graphing of an inequality other than just making it dotted versus full. As is always the case, either in an equation or inequality, we're looking for values that make it true. Well, what exists in a linear inequality is that due to the nature of an inequality, there are going to be many, many points that are going to make this true. All right? And what we find is that essentially what this line gives us is a boundary where one side of it is going to give us points or values that make it true, and one half that will make it false. And so it's up to us to figure out which side that would be. And so an easy way to do that is to take a point that is clearly on one side or the other of this line. Okay? As a general rule, we like to use the origin, 0, 0, because that's very easy to plug in. So, 0, 0 is here, so that is clearly on this side of the line, and let's see what happens. If we plug in 0 and 0, is 0 less than 0 plus 1? Well, it is. And so this point on this side shows us a solution that works. What that points to is that this whole side is going to be solutions that make this true. All right? And that means that this side will be solutions that make it false. And in linear inequalities, the way that we deal with that is we shade this entire side. We obviously can't plot every single point because there's an infinite number of points covering the entire side, so the best we can do is just to sort of color it in or shade it in. Okay? And then leave this blank. And again, what this signifies is that all of the points on this side of the line make it true. All of the points on this side of the line make it false. And because it's less than and not equal to, the points that make the line itself also don't work, but we need this as a boundary, because everything this way works. Okay? And so that's how we graph a linear inequality. Just to go back to the beginning for a sec, it's really important to remember that even though the inequality is the new concept here for us, we really need to relate it to this, okay? Always go back to when we're graphing these, turn it into an equation first. See the equation, graph the equation, and then use that as a boundary. Okay. Once we've learned to do that, we're then going to say, okay, well, what happens if we're asked to graph multiple linear equalities on the same coordinate plane? What are we after there? Well, we're going to start in the same way. That is, we're going to take a look at this, and we're going to graph it just like it were a linear equation. So we're going to really treat it as if it were x minus y equals 4. And so we want to find points on that. Again, we could put this in the slope-intercept form. We could also just plug in values. It's not very difficult for us to figure out x and y values that subtract to make 4. For instance, I know that 4 minus 0 works. I know that 5 minus 1 works. I know that 3 minus negative 1 works. And so our line should start to shape up like this, okay? Now, the difference between this one and the previous linear inequality is that this is not greater than or just less than. This is greater than or equal to, which means that the points on this line actually do work in the inequality. And so rather than draw a dotted line in this case, because of this line here, because or equal to, we can draw a full line. Okay? And so that's what that looks like. And now we just need to figure out which side should we shade. And so again, we go to the idea of, okay, let's pick a one point that is clearly on one side or the other. Again, the origin works great. Okay? So is 0 minus 0 greater than or equal to 4? Well, it's not. 0 minus 0 is 0. 0 is not greater than 4. So this side would not be the side to shade. It means that this side would. Now, as a rule of thumb, it's good to always go in and check one on that side just to make sure. So let's go out and say, okay, how about 5, 0? Is 5 minus 0 greater than or equal to 4? It is. So that means that we would shade this side. Now, I'm not going to shade that very heavily at the moment, and you'll see why in a minute. Taking a look at the second line. Again, we're going to graph this. It's an inequality. We're going to treat it as if it were y equals 3x minus 1. And we're going to plot points. We'll use the slope-intercept in this case. So the intercept is negative 1. Has a slope of 3, so that means I go up 3 over 1, up 3 over 1. Now, this one is not or equal to, so I'm just going to use a dotted line. And I'm going to draw that one. So this line should look like that. And again, let's figure out the side of shading. So 0, 0 is clearly on that side of the blue line. And so if we plug in 0, 0, what happens? Is 0 less than 0 minus 1? Well, 0 minus 1 is negative 1. 0 is not less than negative 1, which would suggest that this is not the side that we should shade. We should shade this side. Okay? And so we end up shading this side. Well, what we end up getting here when we graph 2 is an area that they both have in common, that they share. And that's really what we're after. So what is the area that they both cover? And if you look at the red line shades down here, and the blue line shades here, the area that they have in common essentially goes from here and here in this direction. And so what we're going to do is we're going to shade that area rather heavily. Because what we want to show here is the values and the points that work for both of these. In that sense, it's kind of like a conjunction or an intersection, because we want to find what is the common ground. And in this, there's quite a wide area of that, and it is embodied in this section here. Okay? So, again, graph each of these as if they are equations, figure out which side we want to shade of these two, and then when we're graphing two of them, we're looking for the area they have in common, and we're going to shade that area heavily to signify the solution.